yesterday? Because at first they had us spreading it all out. But what shortcut did we learn yesterday? What about the exponents? What shortcut did we learn yesterday? Well, when can we add the exponents? What's the situation that lets us add the exponents? What's the situation that lets us do that? So if I did, remember the multiply is the shift dot. Can I add those exponents? Don't write this down, just checking for knowledge. Can I add those exponents? Oh, they have to have the same base. Well, what part's the base? What if I do this? Can I add the exponents now? They both have 3. Oh, the big number that has the exponent on it, we have to have the same. Okay, good. All right. So this one won't work because they don't both have the same big number. Is that what we're saying? Okay. Now, so we're still building on that. We're doing that same kind of concept. First things first, our name. Why is this so big? Oh yeah, that's right. Personal finances worksheet. I had to zoom way in, and if I only used 14, it was teeny tiny writing. So I had to make it super big writing. Okay, so Mrs. C, period 2, maybe. Okay, so we are doing the same kind of concept as we did yesterday. As long as they have the same base, we're allowed to add their exponents. We're going to do some color coding to keep our thought processes in sync with each other. Okay. And so we remember which pieces are allowed to be together. Okay. If there is no exponent showing, what number is automatically there, even though we don't see it? Same number that's always been there. The number 1. Because as soon as I see a Y, there's one of them. Okay, so first thing we need to do is color code and see how many pieces we have to worry about. I see a base 10 and a base 10, right? And then I see an x to the 3rd. Do I see another x to the 3rd? Do I see another x? No. So then we have to get a new color, and there's a Y. So we get to do the exact same things we were doing yesterday. Okay, we know automatically that as soon as we see it, there's a number 1 in the sky, just like there was a 1 in front of, right? I'm going to fix the second one because you didn't write as pretty. Okay, so those have 1s, even though we don't see the 1. Okay, so we have to worry about the 10 to those. This is no. We start with the 10s. We have 10 to the 2 plus 1, right? And an x to the 3rd and a y. I don't have to worry about the to the 1. I need to clean up the 10's exponent. What's it going to simplify to? 10 to the what? Ten to the what? Yes, 10 to the 3rd, arrow off, x to the 3rd, arrow off y. Okay, there's our final. We made it as easy as it can get. We can't combine the X's and the Y's because they're not the same thing. Okay. How many bases do we have this time? Remember, bases are original numbers. How many colors would I be color coding with is the question I'm really asking. There are two different bases. Because remember, we color code same bases, same color. So how many colors would I be using? Just one. Yeah. Because we only have 20s. We don't have the X, we don't have the Y, we don't have another number. So this one's a quick and easy one. 20 to the 3 plus 8. Next line down, simplified up. What is it going to be? 20 to the what? Do the math. What do we get? Do the math. 11. Okay. So look at carefully. How many colors am I going to need? How many different bases do I have? 3, because I have X, I have Y, and I have Z. So X with X, Y, I only see one of those. Z, I see 2 of those. We're going to do the same thing we just got done doing. For the ones that have more than one, we're going to show the math. Oh, wait, I want to go back to this one. There's my final answer. Okay, so X to the, what numbers am I going to add together for the X? What numbers am I going to be adding together for the X? Yep, 2 plus 3. And then we arrow off Y. Are we going to be adding together for the Y's? No, so we just have the same Y we already had, which is to the second power. And then we have the Z's. What numbers are we going to add together? Remember, shift 6 is the exponent. What numbers are we adding for our Z's? Look at the Z numbers in this guy. What am I going to add together? I don't think the Z has a 3. I do see a 5. We're not spreading it out. We're just looking at the numbers in this guy attached to the, it's a 2 plus a 5. Yeah. So remember, we're not spreading it out anymore. We learned that there's a shortcut, then we can add them together. And that's what we're doing. We're showing adding them together. So what is the power on the X going to be now? 5. What is the power on the Y going to be? Still 2. What's the power on the Z going to be? 7. All done. Okay. Questions about that one? That was the same thing as we did yesterday. We got to skip the spread it out part first, though. Kind of nice. So Aaron wants to rewrite 5x squared, 5 squared x squared times 5 to the 4th x to the 3rd in a simpler form. She started by expanding the expression like this. 5 times 5 plus x times x plus 5 times 5 times 5 times x plus x to the 3rd. And she got this big thing. Do you agree with her work? Did she do the right thing? No. What did she do wrong then? Because we have to tell her what she did wrong. What mistake did she make? We do not agree with Erin's work because I don't think she multiplied the base. Remember, she was writing an expanded form, which is where we started yesterday, right? And we look at her original problem and then how she expanded it. Who sees a mistake in the expansion process? We're not worried about the base yet. Who sees a mistake in the expansion process? You have to go look back at the table we made on yesterday's notes. Were these involved at all yesterday? Should we be using addition in our expansion form? No. So we do not agree with Erin's work because, someone tell me why. What can we say to her? What can we tell her she did wrong? What should those have been instead of addition signs? No, not a parentheses. Look back at yesterday's table. Very first problem we actually did together until we backtracked. Oh, there should not be any addition on this because our problem to start has no addition symbol, right? Because she added the factors instead of multiplying the factors. That was a problem. She can't add them. There's no addition in this problem right here. Because we're comparing this problem right here. There's no plus signs in that. So there should be no plus signs in your expansion. Okay, so now let's expand this correctly. We're expanding it correctly. So it starts with a 5 to the 2nd power, arrow off, x to the 2nd power, shift 8 to make the dot, 5 to the 4th power, x to the 3rd power. That's what she started with, right? Let's expand this the correct way. Show me what we would do with this first term. 5 to the 2nd power, x to the 2nd power, what would the parentheses look like? Expand it correctly. What would the parentheses look like? Just like we did on the table yesterday. We have to do the whole thing because 5 to the 2nd power, x to the 2nd power, that's one term. They go together in the parentheses. So 5, shift 5, shift, what else goes in this parentheses too? We need all the pieces together. So I'm looking at this first term. and I'm expanding it. And then I'm going to expand the second term. Okay, so we're expanding the first term and we're expanding the second term. There's not going to be any 5s in this parentheses. The pink has 2 5s and that's all. What else does the pink have that we have not mentioned yet? So give me the whole parentheses, all the parts. What would the parentheses completely say? Yes, thank you. We need our XX. Okay, and that's multiplying times the second one's parentheses, which would look like what? If we expanded it out. What's the blue's parentheses going to look like? Thank you. 5, shift 8, 5, 4 of them. And then X with X with X. Remember, shift 8 is where we're getting the dot from. All right, so now we're going to combine our like things. I have 5s that I have to pull together. And I have X's I have to pull together. Okay. So that's a 5 to the 2 plus 4 and an X to the 2 plus 3. Oops, plus 6. Because we can count them, right? So the actual real simplified form is what? Do our math for our exponents. We rewrote it in shortcut form. If someone's wondering where that came from. So what's this going to be? Pull it together. Do the exponent math. 5 to the what? X to the what? Tell me. 5 to the 6th. Oops. To the arrow off. X to the 5th. Yes. And we can confirm that by counting. Right? We can confirm that by counting. I see 6, 1, 2, 3, 4, 5, 6, and 1, 2, 1, 2, 3, 4, 5. Okay. So we can confirm it by counting. Okay. Okay, so it says, when a number is raised to a power and then raised to a power again, the following shows a consistent pattern. Complete the table. Complete the table. We are going to expand each expression first into factored form and then rewrite it. So we're learning a new rule. Okay. So if I'm going to do this in expanded form, first I figure out how would I spread out the parentheses part. They did 5 to the second power was a 5 times 5, right? How would we do this one's parentheses form? And we're going to want to be at 12. How are we going to rewrite the new parentheses for number 2, this parentheses here? So we're looking at this 2 parentheses. What is the expanded of that? Yes, 2 times 2, right? That's our expanded for that. 2 times 2. Now, what happens though is that 2 times 2, it's 4 sets. See the exponent says 4? So I need 4 sets of this. There's 1, 2, 3, 4. Because they said 2 to the second power, we need 4 sets of it. Okay? So if we go do our math, how many 2's do we actually have then? 2 to the what power? Count how many 2's are there. Eight, so 2 to the 8th power. Okay, next one. This says 3 to the 7th power, so I need to make a set of that. So I need 3 to the 7th power. That's going to be 3 times 3 times 3, 7 3's in a row, right? 6, 7. And then the outside exponent tells me how many sets of that. How many sets of that do I need according to the outside parentheses, outside exponent? So we expand the inside, and then we have to make however many sets of that the outside tells us. So the outside one is telling me how many sets of 3 to the 7th power. 2 sets. So I'm going to copy and paste one more, so I have 2 sets, right? So if I do that, how many 3's do I really have? So first we have to expand the parentheses. Then we look at the outside for how many sets of that parentheses. Okay, so what's the next one going to say? Expand the parentheses. What's it going to say? Expand the parentheses. What's it going to say? Expand the parentheses. The inside, what's it going to say? Thank you. X, oops, times X, because that's X to the 3rd power. And then the outside tells us how many sets of that. How many sets of that do I need? Altogether, 5. So I have 1, 2, 3, 4, 5, right? So that means how many X's altogether do we actually have once we've expanded it? X to the 15. Because 3, 6, 9, 12, 15, right? Okay. Expand the parentheses. What are we going to have? Expand the parentheses. What are we going to have? Okay, thank you. And then the outside tells us how many sets of that. So how many sets of this X times X times X times Y times Y? Because it was 3 X's and 2 Y's. How many sets of this do I need? According to the outside exponent, 2 sets. So I'm going to copy and paste one more set. Okay, so I have to pull the like things together. So we're going to color code this one. I see X's in both, and I see Y's in both. So I need to pull those together. So what's my simpler version going to look like? Yes, because I see 3 orange X's and 4 blue Y's. So X to the 6, that's not an X, that's a Y. X to the 6, Y to the 4. Okay, so we got our table finished. Now we got to talk out what we noticed happened. Now we have to talk out what we noticed happened. I should see your eyes, not your foreheads. Come on. So we've worked together to finish the table. We now need to work together to find out what we need to describe the pattern between the exponents of the original and the exponents of the simplified. Who sees a pattern? What do we notice happened this time? We didn't add the exponents, did we? If I'm comparing from my original form, 5 to the 2 to the 5th, 5 to the 10, 2 to the 2nd, 4 of them, 2 to the 8th. What do we notice is happening this time with the exponents and the bases? Yes, this time we're multiplying the exponents because there's multiple sets of what's inside the parentheses. So if they have the same base, then the exponents from the original get multiplied to make the exponent, can't spell, sorry, of the simplified form. Right? That's what happened. That's what we noticed happened, right? They have to have the same base, though. That's still ultimately the important thing. Okay? Ultimately, they have to have the same base. So this one says, let's see, visualize 20 to the 3rd power 8 sets in factored form. What is multiply? What is base? How many times is it multiplied? Use the expression you visualized to write a simplified form. Describe in detail how you figured it out. Okay. So we're not going to do this expanded form, right? It says to visualize, which means we don't write it on the paper. But we do need to explain what is multiplied, what is the base, how many times is it multiplied. Okay, so we have to start there. Okay, what is being multiplied? What is the base? And how many times is it being multiplied? So we are looking at what they gave us, this expression right here, 20 to the 3rd power to the 8th power. We're thinking about how this chart worked, and we're coming up with some sentences about what is being multiplied. Okay. We are multiplying the exponents. Okay, what is the base? Now, what are the exponents? What are the numbers on the exponents? What exponent numbers would we be multiplying together? What are they? Okay, 3 and 8. The base is 20. And how many times would it be multiplied? So actually, what is being multiplied? The 3 is being multiplied. So let's go like that. The exponent 3 is being multiplied. The base is 20. Now we're going to put in the 3 is being multiplied 8 times. And we're going to add a note to ourselves in parentheses, the outside exponent. And we're going to make the 3, when we say here, we're multiplying the 3. We're going to shift some words around. The inside exponent, right? That way, we're not linking it only to the numbers 3 and 8. We're linking it to the idea that the inside exponent is the one that gets multiplied. The base is still the big number, and it's multiplied times the outside exponent. Okay? So now we have to simplify this one doing the math. I have 20 to the 3 times 8 now, instead of 3 plus 8. So 20 to the what power is our final answer? Three times 8, guys. $24. So 20 to the 24. That is a gigantic number, by the way. Okay. So we looked. So we're going to describe in detail what we did. So we're going to make it generic now. Okay. No. To solve this type of problem where there is an inside exponent and an outside exponent, you keep the base and multiply the exponents together to get the simplified form, right? That's what we did. Yeah? Anybody not understand how that worked? Okay. In problem 59, which is the one we just did, we simplified 20 to the third and 20 to the eighth. Compare your factored form you wrote for the expression. So we need to write a factored form. So we need a factored form. So what would it look like as factored form now? Factored form is this stuff in the middle of the table. This is factored form. Expanded factored form. What would that be? How would I show the expanded factored form of 20 to the third power to the eighth power? So I want this 20 to the third power to the eighth power. I want to expand this one first because we're comparing to this one here. So first we expand this one that's in orange. Then we're going to expand this one that I'm putting in green. Okay, so how would we expand the one that's orange? Just like we did on the table, show me how to expand the one we did right here in orange. How can I rewrite that? Yes, 20 times 20 times 20. And we need how many sets of this? 8 sets. So 1, 2, 3, 4, 5, 6, 7, 8. Whew. Right? So this is the expanded form of, I'm going to put in the front right here, parentheses 20 to the third, I can write it. You have to arrow off the 3 to do the parentheses and then do the to the 8. Okay, so that's the expanded form of that one. Now we need to expand this one here that they give us. Okay, so we need to expand 20 to the third times 20 to the 8. Okay, how would that look expanded? What would the first parentheses be? The 20 to the third, which is the same, right? 20 times 20 times 20. But what's the second parentheses going to look like? We need that 20 to the 8th. We need that 20 to the 8th power. What would the parentheses look like for that one? I need this second factor right here, 20 to the 8th, as a parenthesis spread out. What's that going to look like? Spread out. Yep. 20 times 2, 3, oops. There's 3, 4, 5, 6, 7. I got to fix that one. 8. 3, 4, 5, 6. I don't need this. Okay. Now, if we go up to this first one and we count all the 20s, how many 20s are there? We go to the first one and count all the 20s that are there. How many 20s are in that first line? 20 to the third power to the 8th power. How many 20s? 20 to the how many? 24. Okay. Then if we look at the second one and we count all the 20s, what do we have? 20 to the what? 11th. Okay, it asks us, compare the factored form, got it, to this one, got it. How are the expressions different? How are they different? What could I say is their differences? Look at the format of the expanded form. How are they different? Look at the structure of the expanded form. That's one way they're different, right? So how could we describe the difference in their structure? How are these simplified expressions different? Don't just focus on the number, focus on the structure. Do each of the parentheses setups in both those rows look exactly identical to each other? The expanded forms, do those look identical to each other? No. So how do they look different? What makes one different than the other? So I'm getting the expressions written down so I can pick one. Okay. One is spread it in chunks rather than all together. That would work. That's this one, right? 20 to the third to the eighth. For 20 to the third to the eighth, the factored form is in chunks. Of, okay, chunks of what? Where did the chunks come from? Where did we get the chunks from? Where did the chunks come from? How did they come to be? Where'd they come from? Where did we get that 20 times 20 times 20? Where did we get this first chunk right here? Just the first piece, just this. Where did that come from? Oh, the inside. Oh, so we expanded the parentheses separately? Ah, so chunks of the inside of the parentheses expanded. And then made, okay, so after we expanded the inside, then what do we do? Then what do we do? After we made that 20 times 20 times 20, then what did we do? Did I leave it there in this one? How did I figure out these? Okay, I need to figure out how many chunks. So we made chunks of the inside of the parentheses expanded. And then after we expanded it, we then made sets of it that matched the outside exponent, right? Yes? So I'm trying to make it a little bit generic so we could use it for things other than 20 to the third power and to the eighth power. So we took the parentheses on the inside and spreaded him out. Then we looked at the outside to see how many sets of it. Yes? How is that different from this second one right here? How is the second one different? Wait a minute, I'm writing it. Okay. There was no outside exponent. That's right. There's no outside exponent. So what did we do for this one? For 20 to the third, 20 to the eighth, comma, there is no outside exponent. So what did we do? What did we do? If there's no outside exponent, then what did we do? We expanded each part separately, right? Which is the same as added the exponents. And in this case, I've got to add that in up here, this expansion part, which means we multiplied the exponents. And I'm going to move that over so it doesn't get in the way. Exponents. Okay. So because the first one had an inside and an outside, we had to multiply the exponents. But the second one didn't have an inside and an outside, it had side by sides, so we added the exponents. All right? Does that make sense? Okay, so because the first one had an inside and an outside, we expanded the parentheses to make the chunks. We copied to make the same number of sets as the outside exponent, which means we're going to be multiplying those exponents. But for the second one, since there's no outside exponent, they're side by side, right? We expanded each separately and added the exponents. Okay, does that make sense? Okay, so let's go to the next one. Heidi is trying to rewrite the two expressions below. Okay, Heidi is trying to rewrite the two expressions below. And the question was asked of her, are these two ways of writing the same thing, or do they mean something different? Heidi wonders. Rewrite 2x to the third power by expanding it, then simplifying it. Okay, so what's going to look like expanded? What's it going to look like expanded? I think I can do that. What's it going to look like expanded? 2x to the third power. How's that going to look expanded? Two x with 3 sets. Yes. Okay. So I'm going to put 2x, 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 right? Now, I told you before, what exponent's there that we don't see? One. So I'm going to go in and I'm going to put those exponents in here. 2 to the first power. X to the first power. 2 to the first power. I'm going to go put my ones in there. Oops, that's not supposed to be a square. It's supposed to be a 1. Okay. Now, if we simplify this, what are we going to get? If we simplify this, what are we going to get? So simplify that expanded form. If we color code it, we have 2's, right? And we have x's. And when I expand it, I see 3 of the 2's. So that's why they said 2 to the 3rd power. And I see 3 of the x's. Okay, so we rewrote in expanded form and then simplify. Now, what part is being raised to the 3rd power? What part is being raised to the 3rd power? Just the 2, just the x, or the entire parentheses? What part was raised to the 3rd power? Just the 2, just the x, or the whole parentheses? The entire parentheses. So the part being raised to the 3rd power is the entire parentheses. And I missed the H. Okay. Not just the 2, not just the 3, the entire parentheses. Because it was inside a parentheses, that means 3 sets. We see that? Okay. Now she thinks that 2x to the 3rd power is the same as 2 times x to the 3rd power. Okay. Can we find a way to show this is correct? So show she is correct by expanding the expression. How would we expand that? What's another way to write 2 times x to the 3rd power? If we spread it out, what would we spread it out to be? If we spread it out, what does it spread out to be? I disagree with that one. Because we're expanding 2 times x to the 3rd power. Look at how they wrote that. Think how that would expand. Because what's in the chat, that's a 2 to the 3rd power and an x to the 3rd power. We just figured that out. Do you agree that what she's written, that pink does not mean the same thing, does it? How would we expand the pink? How would we expand that pink? What piece needs to be expanded? The 2, the x, or both of them? Only the x, that's right. So it's 2 times an x times an x times an x. So does that mean the same thing as 2x to the 3rd power? Do these two things mean the same thing? Does 2x to the 3rd power equal 2 times x times x times x? Yeah. So she is correct. Because only the x had an exponent. That's the only piece that's going to be expanded. So are 2x raised to the 3rd power and 2x to the 3rd power the same? So we're going to copy our final answers. Let's look. Here is the simplified form of 2x raised to the third power. Okay, this is our simplified form of 2x raised to the third power, right? And this is the simplified form of Heidi's. Do those mean the same thing? Are those completely identical in every way? So can they be called equivalent if they're not completely identical in every way? No. So are these two equivalent? What are we going to say? Are we going to keep an equal sign or are we going to change it? Are we going to say those are equal or are we going to change it? Change it to the not equal. Remember, go over here. So we're going to highlight the equal sign. I'm going to go into my tools. I'm going to pick the not equal. Try again. Not equal. Okay. They are not equal. Those do not look identical to each other. Why not? These are not equivalent expressions because why are they not equivalent? What's different between the two? What's different between the two that made it not equivalent? Ugh. What's different between these two? So we said not equivalent. Why? We have to be able to verbalize it. What do we see that's different between them? Because we said not equivalent, so why? Ah, exactly. For, I'm gonna go over here, remember? Parentheses 2x to the third power. And we're just gonna move them where we want them. The exponent went for all parts inside the parentheses. I'm having a parentheses spelling day. Parentheses. But for 2x to the third the exponent was only for the x. Nice. Okay. So you have to watch where the exponent is. If it's not in parentheses, the exponent does not apply to everything, just the piece it's attached to. All right. Save and submit that assignment, please. Turn it into the Google Classroom, and let's get assignment 2 open up so we can do part of it. Okay. Save and turn in class chapter 8 activity 2.